Okay. Oh, I'm on the wrong page. That's the right page. Fundamental counting principle. Few people have asked me why it says FCP on the back of the calendar, but that's what this is for. Fundamental counting principle. Yes. Pointing. We call it pointing. Okay. And truthfully, just flipping it over doesn't.
But it's turned off.
It is not. You left it on so that it would keep collecting.
No, it's not. You see this?
So yeah, you literally just hit the power button and just flipped it over.
It's,
I understand how phones work.
you said it was like all
If I see you flip it over again, I'm taking it. Avoid the temptation to check your game.
It's just.
I know. What I was trying to say is I don't care if you know the name for this or not, you just need to know how to use it. That's all that matters. None of the topics we learn, you don't need to know the names of what they're called. I teach you the name so that if you want to try to tie together a name to an idea, you can. But you never have to memorize all these names, especially with this probability unit, like every other page is a new name. So this one starts off by talking about tree diagrams. Yeah,
Oh, you charging? Yeah. Okay. Get it.
let's shut the Chromebooks. We don't need them. There we go. Most of our sections we can get done pretty quickly, and then if you have other work to do, you are welcome to do it then. Okay, fundamental counting principle starts off with tree diagrams, which I believe you have learned before, but maybe you forgot the name. So I will draw a tree diagram for flipping a coin. A tree diagram starts with a dot. That's going to be your decision, okay? Or I shouldn't say decision. It's going to be your event. So like in this case, we're going to flip a coin. So that dot stands for we are going to flip a coin. Different things can happen when we flip a coin. We can get a heads or get a tails. Now, a tree diagram looks really, it doesn't look like a tree at all when you only have two things total. The purpose for the tree diagram is to try to figure out how many things are in the sample space. Excuse me. So it'll start to make more sense when we start to have more options, but then at that point, a lot of people don't like the tree diagrams because they're too big. So let's flip two coins. Start off with a dot. We're going to flip a coin. Two things can happen. Okay, well, if I follow the tree branch, so I flip a coin, let's say I got a heads. I would flip a coin again, because I'm flipping a coin twice. And two different things can also happen. And I would have heads, tails underneath heads. Or if I go back up and tails was my original choice, then I would flip a coin for a second time.
Mr. McCall,
Go for it.
it kind of looks more like a mountain range.
Sure.
Like then like.
If you flip the whole thing upside down, it's supposed to look like a tree branch.
Oh, it kind of does.
Yeah. Well, that's okay if you don't see it, that's what a tree looks like when it grows. That's why it's called a tree diagram. There are 4 things on the bottom row, and so for flipping 2 coins, you would have 4 things in the sample space. Again, that's kind of what the tree diagram is for. People who are better at visualizing things like this method because they can literally draw to find the answer. People who are better at thinking or using formulas don't like this way because they don't like to take the time to draw. Do you guys think why don't you guys try to draw the third one? If you haven't already on your own, try to draw, flip a coin first, then roll a number cube. My tip is to make sure that your first branch is very wide, because you're going to need space underneath it.
Do you want to help? Because I've had, if I like write it, I'm like, I can't erase it.
Strangely enough, I keep a cup of pencils that apparently has been robbed, very empty. It is weird how a lot of people don't put the pencil back.
I'm scared. Yes. What can I say?
I started off last year with 600 pencils. This is what I'm down to.
What can I say?
We don't have many left. Taylor, you were the one that we were supposed to call on first. Do you want to answer this or do you want to give me a number? Okay, what's the number? Oh man, why does everybody pick such a big number?
Did she say 20?
1, 2, 3, 4, 5, 6, 7, 8. Now, would you like to draw what you got for the tree diagram, or do you want to just tell me what the sample space should be after you draw?
I'll just draw it.
Okay.
What's the other option?
Oh, you're brave. You started off with your branch very skinny. Oh my gosh.
Oh, body shape.
Actually, that's pretty hard to see.
Yes.
Just rats.
Your knuckle hit the board. Palm. A palm is the eraser.
What can I say?
Gessler. How many branches did you end up with on the bottom? 6.
There's 6-sided dice.
I bet you're counting wrong. Did you not draw it? Oh, you only drew half of it. So there'd be 6 of these. Okay. The second item is a dice which has 6 sides, but the 6 things should be on each heads and tails. Every branch that you draw has to have a decision. So heads, tails first, and then each heads and tails, both you're going to roll a number cube and have 6 possible things coming off of it, and that would give us a sample space of 12. Now, the day I was gone, essentially my mint and candy stash got robbed. So I have very few left. But I was hoping somebody figured out the answer to this. Perfect. You can multiply the number of choices. If you are a visual person, drawing this is great. If you're a formula person, you multiply the number of choices each time. Flipping a coin, well, there's only one choice. Flipping two coins. The first time you flip a coin, two things can happen. The second time you flip a coin, two things can happen. Third problem, flip a coin, two things can happen. Your second decision, you're going to roll a number cube, 6 things can happen. And you can multiply the number of choices. That's actually what the fundamental counting principle is that you can multiply the number of choices. Nice job. You can have one of the 6 or 7 remaining minutes. Thank you. Okay, up above, you probably want to write down what the fundamental counting principle does. You can multiply number of choices.
Oh.
It gets old. I understand. It gets old hearing. And multiplying the number of choices finds the sample space. So whenever you have a question that's going to ask you, how many possible choices are there? You can draw a diagram, but realistically, sometimes that's not really possible. It's just going to be too big. So, or you multiply the number of choices. Okay, this one is a 5-sided spinner. And it says you're going to flip a spinner and then flip 2 coins. Who should we go with? No. Let's Leo. What would I multiply for this first one? How many choices do we have spinning the spinner? 5. Okay, what about flipping the 2 coins?
4. I'm not the same person.
That's very true. Why 4? You weren't wrong. But I would think you're not going to want to write a 4 immediately. So flipping 2 coins, write them separately. So flip the first coin, 2 choices. Flip the second coin, 2 choices. So the 4 was correct, but you might confuse yourself if you break that. So you would have 20 possible things in the sample space. And we could draw the diagram. I am most definitely not going to. Flip a coin, spin a spinner, flip a coin.
Same thing.
Isaac. No. Flip a coin first. 2. 5. 2. 20. Jaden. What is this teaching us? If we can do the spinner, flip a coin, or flip a coin, spin, flip a coin, and we get the same answer. What is that teaching us? Doesn't matter the order you do it, you would get the same answer. Because we're just multiplying them, the order you do things won't matter. Yeah, no, what you said works, because that's essentially how it is. Oof, okay, now you go to Applebee's or your favorite restaurant. Generally, Applebee's and Chili's are the restaurants that have something like this, where they have, like, I think it's Applebee's right now that you have a, what do they call it? A meal for $10.99. You get an appetizer, a burger, and fries and drink. So they,
That's a good deal.
yeah. Hmm? Yeah. I mean, those two restaurants frequently have deals where you pick options and it's a certain price. This one says for $20 you get one appetizer, one entree, one drink, and two desserts. How many different ways could you order your meal? What do we multiply? David, what should we multiply on this one? Nothing? 0. That's a terrible option. I don't want to eat that. That's 0 option. How many different appetizers are there? 4. Okay, so I order my appetizer first. I've got 4 branches. Each one of the appetizers, I could order how many different entrees? Good. Drinks. 3. Desserts. Now, here's the sticky part. Well, that is terrible pun. I'm not trying to do that with dessert. This says you're supposed to order 2 desserts. What it didn't clarify to me is it didn't say if you can order 2 of the same desserts or if you have to order 2 different desserts. Because that actually matters. If we can order the same dessert twice, well then we have 5 more options. If we have to order a different dessert, we would only have how many options the second time? 4. So I'm going to pretend that this says 2 different desserts. Because then that way this question's a little bit different, a little bit harder. And I like that better. I don't want every question to be easy for you because that doesn't help you learn anything. And this is a big answer. We've got 64 times 5, 320 times 3, 960. 960 meals. Now, when you're really hungry, that sounds fantastic. And Applebee's and Chili's should absolutely advertise that. You can order 960 different possible meals. You could go every single day throughout a year. You could go for 3 years in a row almost and have a different meal every day. Yeah, that's why I said almost. It's rough. 365 times 3 is probably a little over 1,000. 2.6 years? All right, there we go. 2.6 years. I don't have to cook supper. However, it costs me a lot of money, so it's a trade-off. Maybe I won't pay for my house instead. Okay, I would like you guys for the next 10 minutes to do the next page. I will give you the answers, and then I'll actually give you your first assignment that we've had forever that you can turn in.
That costs $9,000. $19,000 for 2.6 years.
Well, 2.6 years, that's not terrible. There's a good chance I would have leftovers too. So this could include my lunch. If I'm a smaller person, this could include my lunch. Oh, I hate to tell you, but why don't you calculate how much a school meal is for an adult, a teacher, for 2.6 years? $5.75 is what adults have to pay for a school lunch. Yeah, that's dumb. I do.
$2,080 for your full year.
$2,080 for each year for a school lunch.
You make that, man.
Which, I bring my lunch most of the time because of that. But then like days like today, I forgot it's conferences, so I had to actually like find some nice clothes. So I didn't get time to make lunch.
It's only like 1,000, there's only 180 days in the school year.
Yeah. Oh, what did you do?
I did 360.
Oh, that includes weekends. We don't eat on the weekends. 1,000? But still. I guess it's not quite like 20,000 though. 20,000 would have a much better lunch.
Yeah, I wish we could do
Maybe I should just get paid more and I can do that for lunch and supper every day.
that. Or we could just
Do they get free lunch?
oh, they get good lunch though.
Is it free? Well, it's free for you guys.
No, but you'd be paying
I bet you staff don't get
like,
it for
you'd be
free.
paying quantity for quality.
No.
Yeah,
Why would you think that their lunch is better?
because they go private school, they pay like 17,
Thomas
I
Academy.
hate to tell you, but that doesn't,
St. Thomas
That
Academy,
doesn't
because I
increase.
see
The
this.
lunch there.
well, wait till you go to college and pay 40,000 a year and find out that their meal plan is just as bad.
It's okay. No, I-
Paying for your school doesn't mean a good life.
Yeah, I know, but I tell them.
It does.
So then why don't you go